Personal finance presentation using Excel. Savings scenarios. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area on the right-hand side, running a different couple scenarios related to investment type scenarios. Remembering that we have looked at time value of money concepts in the past and run similar scenarios at that time. We want to use those tools now and apply them to what we're currently looking at, which are going to be investment type of strategies as one of the financial services we might want to be looking into when thinking about our financial institutions. If you want to look at these concepts of time value of money in more detail, take a look at the prior section where we focus specifically on time value of money. Now we're going to use those tools and apply them when applicable. So we're looking at a savings scenario here. So if we put money into some kind of savings account and we have the 1,550 and we're going to earn a rate of return that we're going to compound annually at the 6%, what would happen if we left that money in there, didn't touch it? We're not putting any more money in. We're just keeping it in there for 11 years, getting that average of 6%. Where would we be in terms of future value dollars? Future value calculation, we can do it with an Excel calculation. Then we'll do a running balance type of calculation. It's going to look like this: negative future value, negative FV. I'm going to say shift 9 on the keyboard. Left. We're going to pick up that 6% in our data. Notice it's quite nice to have the data on the left-hand side so that you can change the data running different scenarios quite quickly. Then I'm going to say comma. We're going to pick up the number of periods. Number of periods is going to be in annual periods, this case. 11% annually, and then comma, we're not going to do a payment amount because we're not talking about an annuity, but the future value of 1. Therefore, 2 commas is what we're going to be putting here, getting us to the present value. That's our starting point, that being at the 1,550. And then we don't even need to close it up. We're just going to say enter, and that's going to give us the future value of the 2,942. Can we prove that to ourselves doing a running balance table, giving us a little bit more information, context about this? We sure can. Let's do it. We're going to start off with 0, 1. That's 1, 0 starting, then 1. And then I'm going to copy this using the autofill feature down to the 11 period, selecting those 2 cells, putting our cursor on the autofill handle, grabbing it with the left click, dragging it on down, auto driving it down to 11 time periods, letting go. Dr. Phil does the calculations. That's why it's called autofill. Not really, but that's why it's a good story. We're going to go Home tab, Alignment, Center, Autofill. So then we're going to say that the amount then is going to start at, I'm going to say equals the 1,550. If we're going to be earning the 6% per period compounding annually, that's going to be equal to the 1,550 times this 6% over here. This item is outside the table. I want it to be able to copy down and not move down when copied down. Therefore, absolute reference needed, although you only need a mixed reference, but absolute works. F4 on the keyboard, $sign before the B and the 2. Enter. Then I'm going to say the running balance equals what we had before, the 1,550 plus the 93 about, and enter. There's no absolute references needed there because both those cells are going to move down respectively when we copy it down. But let's not copy it down yet. Let's do it 2 more times just to practice this. Now we have the 1,643, which we're going to be multiplying times the 6%. If we were to copy it down, F4 on the keyboard, making a $sign before the B and 2 so it doesn't move when copied down. And now we have a higher amount of increase, which would be interest or dividends or gains, whatever, in whatever fashion. This equals the prior balance plus that 99 on the left. I3 plus H4. Let's do it one more time before auto-filling it down. We got the 1,742. We're going to say times the 6% again. F4 on the keyboard, $sign before the B and 2. And then we have the 1,742 plus the 104, now at the 1,846. Let's delete this now and then do it again the easy way. Let's do it the easy way. Let's delete this whole thing. No, oh my, all that work. That's okay, because this time we're going to do it the easy way. This is going to be equal to the 1,550 times that 6%, F4 on the keyboard, $sign before the B and 2, enter. This is going to be equal to the one above it, 1550, plus the one to the left of it, 93. Enter. Selecting those two cells so that we can grab the fill handle. There's the fill handle, grabbing it by left-clicking on it, and then dragging down, holding the left click down to the 11 periods. Auto drives it down, letting go. Dr. Phil does the calculation, and it auto-fills bottom line number at the 2,942, equaling the 2,942 that we came to up top. We can see how the increases over time due to the compounding on an annual basis. Next scenario, common scenario, we're saving for something. This time we're going to say we're saving for college. It's going to happen in 8 years. We need $20,000 in order to basically spend during that time period. We have 8 years to save $20,000, in other words. Now, note, we go into some more complex scenarios on these if you want to take a look at the present value and time value of money calculations, because we might do a calculation to determine how much we would need at the point of college starting, and so on and so forth. But in essence, if we need some form of money in a future time period, at this point we're saying $20,000 in 8 years, you could do a similar calculation if you need some money to save for retirement or to save for a college fund, a car, or something like that. Then how much would we have to be putting in order to get to that point in time? The rate we're going to be using of growth is going to be the 7%. Now, this one's it seems a little bit confusing because we're saying, okay, how much would I need to put down now, earning 7%, to get to the future of the 20,000? So what we want is actually a present value calculation, because we're saying that 20,000 is what we need in 8 years, 8 years from today. If I pull it back to today's numbers, that should give us the number that if we invested now would then grow, if growing at 7%, to get to the 20,000 in 8 years, which is the amount that we've determined that we need in future valued dollars at this point. So we're just going to do this trusty present value calculation. Now, this is not an annuity we're assuming. This is just one lump sum we want to put into some investment now that will grow at 7% to get us to the 20,000. All right, negative present value, shift 9. We got the rate 7% here, and we're pulling this from our data on the left-hand side. So once again, we could run different scenarios by just simply changing the data on the left. And then we're going to say, comma, number of periods, 8. Pulling that data from the left-hand side is common practice for, when you're building your worksheets. Comma, we're not having a payment because it's not an annuity. So 2 commas, future value, the 20,000. That's how much we need in 8 years. How much is the equivalent amount today if we can grow it at 7%? It is suspense, building suspense here. Enter 11,640. So if we put 11,640 in today, earning 7% for 8 years, we would be at the 20,000 that we need in that time frame. Can we prove that by doing a running balance calculation? I think we can. Let's try it. We're going to say 1, 0, 1, and then we'll autofill, selecting those two cells, autofill it down, grabbing the autofill handle, left clicking on it, dragging it on down to 8 time periods. Let's center that by going to the alignment group and center it. We're going to start off with the amount. This time I'm going to start off with that 11,640, build it up to see if we get indeed to the 20,000 at the end of this 8-year time period. So we're going to say this is going to be equal to the 11,640 times the 7%. If we were to copy that down, we'd say F4 on the keyboard because that 11% is outside. Remember, you only need a mixed reference, but we're using an absolute one here, $ before both the B and 19. Tab, this is going to be equal to the 11,640 plus the 815. That brings us to the 12,455. Let's do it 1 or 2 more times. This is going to be equal to the 12,455 times the 7%. F4 on the keyboard. If we were to copy it down, $ before the B and the 19 tab, this is going to be equal to the 12,455 plus the 7,872. We don't need any absolute references here because both those cells need to move down in relation. Then we're going to do it one more time, the 13,327 times the 7%. If we were to copy that down, we need an absolute reference, F4 on the keyboard, $ before the B19. This is going to be equal to the prior amount, 13,327 plus the 933, giving us 14,260. Now let's do it the easy way. I'm going to delete these ones here so that we can redo it the easy way using the autofill. Delete. No, it's okay. We're going to say this is going to be equal to the 11,640 times the 7% F4 on the keyboard, $ before the B and 19. This is going to be equal to the 11,640 plus the 815. Then we're just going to select those two cells, put our cursor on the autofill handle, grab that handle, get a good grip on it with the left click, holding it tight so it doesn't slip out of your finger grip. And then you drag it on down. And there we have it. And we do indeed end up at 20,000 at the end, which is just the amount that we need, we've determined at that point in time. So what happened is precisely the thing that we predicted planned to happen. So here we go. Let's do it one more time. Deposit per year. This time an annuity calculation. We're saying, what if we put down per year 2,300 into, say, a retirement account or something like that, and we did that for 20 years annually, and it was earning 5% compounding annually? How much would we have in the future value? This annuity calculation, once again, we practice a lot of these calculations in the time value of money section, so I'm going to do it a little bit more quickly here, but go there for more fun times like this. We got the equals or negative future value, shift 9. We're picking up the rate this time at the 5%, comma, number of periods is going to be 20 periods in years in this case, comma. This time we will be using the payment amount because this time we are talking about an annuity, meaning we're going to be putting down $2,300 per year for the 20 years, in addition to the earnings that we're going to be earning on it, which is 5% compounded annually, which will get us where will we be at retirement if we did that? Suspense, enter, 7652, we're saying. Can we prove that? Can we prove that with a bit more complex of a table? We can. It's a little bit harder, but we can do it. I think we could still do it. So I'm going to say 1 and 2 here. We're going to autofill that down to 20 time periods. That's a lot of time periods, but it's easy to do because we've got Excel. We'll put our cursor on the fill handle, drag it on down 20 time periods, down to 20. Let go. There it is. Alignment. Let's center those items. And notice I'm starting at period 1 because a standard annuity means that the payment happens at the end of the time period here. So be careful with that. That's often where people get confused. So this is going to be equal to the 2,300 ending amount. We're not going to show any gains on that because we're showing that amount is going to start at the end of the time period. So now we're going to have the increase in period 2, which is going to be that 2,300 times the 5%. If I was to copy that down, because this is outside the table, I'm going to say F4 on the keyboard, making an absolute $ before the B and 29. You only need a mixed reference, but absolute works. The payment, I'm just simply going to say, is always going to be the same. So you could pick it up from the one above, which I do sometimes, or you can pick it up from the item over here. If you pick it up from the item outside the table, you got to make it absolute F4 on the keyboard, $ before the B and 27. You don't have to make it absolute. You could make a mixed reference, but I'm going to make it absolute. You got to do something to it because you need to copy it down. And then this is going to be equal to a little bit more complex, the 2,300 plus the increase plus the payment, which I'm going to do with a trusty sum function because that's the most professional looking way to do it. So I'm going to say sum, shift 9, left arrow, holding down shift, left again. Got to close up the bracket so it gives you an error sign, meaning if I don't close this up and I just hit enter, it does that. And you say, okay, yeah, close up the brackets. And then it does it for you, but it doesn't do it like automatically. So it's nice to close up the brackets so it doesn't beep at you like that. So we'll do it this time. Let's do it a couple more times. So we're going to pick up this amount, which is at the 4,715 times the 5%. If we were to copy it down, we want F4 on the keyboard, $ before the B and 29 tab. The payment is always going to be the same. That's going to be another 2,300 we're going to be putting in. If we were to copy it down, we want to put F4 on the keyboard, $ before the B 27. Absolute reference, in other words. And then this time I'm going to close up the brackets as we do this. We were at last period in period 2. We were at 4,715 plus the SUM sum, shift 9, left arrow, holding down shift, left again, shift 0, closing up the brackets. So when I hit enter, it doesn't beep at me and give me that error message. It just does it like that. So let's do it one more time and then we'll use the autofill. We got equals the 7251 times the 5% absolute reference F4 on the keyboard, $ before the B29 tab equals the payment of the 2,300 F4 on the keyboard, $ before the B27 tab. Then this would equal the one above it, the 7,251 plus the SUM sum. Shift 9, left arrow, holding down, shift left again, shift 0, closing up the brackets. And there we have the 9,913. Now let's do it the easy way. I'm going to delete this stuff and just do it one more time, thinking I'm going to do it the easy way this time. This is going to be equal to the 2300 times the 5% F4 on the keyboard, $ before the B29 absolute reference. In other words, this equals then the 2,300 F4 on the keyboard, $ before the B and 27 absolute reference. Once again, in other words, this equals the prior balance, the 2,300 plus the SUM sum. Shift 9, left arrow, holding down shift, left again, shift 0, adding the 2,300 plus the 115 plus the 2,300. None of that needs absolute references because they're all inside the same table and they all need to be moving down relative to the cell that I'm copying down. So then we can just select those three cells, put our cursor on the autofill handle, make sure you got a good grip. You chalked up your grip finger that you grip the fill handle with so it doesn't slip. And then we're going to drag it on down to 20 periods down here, and we end up at the 7652, which matches the 7652 that we had up top, and you can see the growth in it. The tables, running balance tables, very useful to put together to get a better idea of what's going on, and it's great Excel worksheet practice too.